Hello and welcome to this video on the IUPAC nomenclature of alkyl halides. And in this video, we're going to talk about how do we do the systematic naming of alkyl halides. And the first thing that we need to understand is that an alkyl halide is a system which has a hydrocarbon chain attached to a halogen somewhere. It could be Cl, it could be Br, it could be F. So it's basically an alkyl halide. So whenever halogen comes up on an alkane, we call it an alkyl halide. Now, to do the naming of such compounds, the first thing that we need to understand is that we do not treat the halogen in any special way, meaning that the halogen is treated just like any other substituent would be treated as. Any other alkyl substituent like methyl, ethyl, propyl, the same way we treat a halogen. So the first rule that we need to understand is the parent chain is the same way. We're going to find the parent chain the same way as we did in the case of alkanes. We got to go for the longest carbon chain. And then the substituents of the halogen are named as fluoro if it is F. Remember this O. And if it is Cl, it is chloro. Bromine is bromo. Iodine is iodo. And these are treated with the same importance as we treat any other alkyl group. Meaning no special numbering has to be given for these except when you want to look at it from the point of view of the alphabetical order. So let's check the first rule. The first rule says the longest chain is to be identified based on the rules given in alkanes. The halogen is assumed to be a substituent just like any alkyl group and is named as fluoro, chloro, bromo, and iodo. So let's do a couple of examples. Try and name this compound. And as is the custom with our videos, I would suggest that you pause the video now and name it and then play it back and then check whether you have named it correctly or not. So now here we're going to look at the longest carbon chain. Obviously, the longest carbon chain happens to be this. Now comes the question of how we're going to number it. Remember the numbering rule of alkanes? The numbering is done so that we get the lowest number for the substituents. Remember, no special preference for chloro. Uh, the fact that chloro is treated just like any other group, except that if you want to check from the point of view of the alphabet, you got to look for C. But in this particular case, the numbering is pretty simple. The numbering has to be done from the left side because that is the only way you can get the first substituent, the lowest number, that is 2. And obviously, you're going to write it the same way as you would write a normal alkane. That means you got one substituent which is chloro, one substituent which is methyl, and chloro comes before methyl in alphabetical order. So chloro is named first, then methyl, and then the alkane. So the name should be 3 chloro, 2 methyl heptane. Let's check one more. Try naming this. Pause the video now. Find the parent chain, number it, name it, then play it back and check. Now here, if you want to look at the parent chain 1, 2, 3, 4, 5, 6, 7, or it could be 1, 2, 3, 4, 5. That doesn't work. So 5 doesn't work. So I think it's going to go for 7 again. So in this particular case, we are going to have this as the parent chain. Now, where do I do the numbering from? If I do the numbering from the left side, this is 1, 2, 3, 4, 5, 6, and 7. So my substituents are in 2, are in 4, are in 6. Let's do the numbering from the reverse side. Let me change the ink color. 1, 2, 3, 4, 5, 6, 7. And again, I get 1 at 2, 1 at 4, and 1 at 6. So the black numbering and the red numbering, they give me the same position numbers. So when there's a choice in numbering, we must give the preference based on the alphabetical order. So which is the one that is getting 2 here? This 2 is for chloro, and this 2 is for methyl. And chloro comes before methyl in alphabetical order, so we choose the red numbering. So the numbering is done from the left side. This is the numbering. So write down the name. Chloro should come first. This is chloro here. This is ethyl. This is methyl. So chloro comes before ethyl. Ethyl comes before methyl. So this is going to be 2 chloro, 4 ethyl, 6 methyl, heptane. Now, what happens if we also have double or triple bonds in this? Well, the rules remain the same. Because as we said, the halogen is treated just like any other substituent. So it doesn't matter if you have double and triple bonds. You look for the parent chain using the same rules that you studied in alkenes and alkynes. And if you want to check back, go back to the videos of alkenes and alkynes to look for the rules that is required to find out the parent chain. So with double and triple bonds present, all the rules used in naming alkenes and alkynes have to be used. So let's do a couple of examples on this. Okay. So look at this one, pretty big, yeah. So pause the video, find the parent chain, number it, name it, check back, and see whether you worked it out right. Now, if you want to look for the parent chain obviously in the case of a double bond is when you have double or triple bonds is the chain which has maximum number of multiple bonds. And if there is more than one chain of that type, then we go for that chain which has maximum number of carbon atoms. So let's try and see if we can do this right. If I take this chain, how many carbon atoms do we get? We get 1, we get 2, we get 3, we get 4, 5, 6, 7, 8, 9. There are 10 carbon atoms. And let me change the color. If suppose I go for right after 8, I go from 1 to 8 the same way, then I make this is 9 and this is 10. So that is another way of getting 10 carbon atoms. So 10 on this side, 10 on this side, both have two double bonds. So the first rule of maximum number of multiple bonds remains the same in both. Then comes maximum of carbon atoms, it remains the same. The third rule for alkene says maximum number of double bonds, even that remains same in this case. So now, once we've exhausted all the rules of alkenes, then we go for the rules of alkanes. Meaning, we now select that chain which has maximum number of substituents. Remember, go back to alkanes and check back. You'll see the first rule for identifying the parent chain is that if there's more than one chain containing the same number of carbon atoms, go for the chain which has maximum number of substituents. Now, let's see. If we were to go for this chain, the one running from right to left, how many substituents do we get? We get a substituent here, bromo. We get one here. We get one here. And we get one here. So that makes it 4. we get 4 substituents if we go for the chain that is running from right to left. Okay. Now let's go for the chain that goes this way. If we do this, then I get one substituent here, one substituent here, one substituent here, and one substituent here, and I get one substituent here. So you notice I've got 5 substituents. So if I were to run from right to left, I would have got 4 substituents. If I go from right and then go down, I get 5 substituents. We prefer 5 more substituents. So the parent chain is this one. And obviously the numbering is pretty simple. The double bond gets the lowest number, so it's going to be numbered from the right side. So this is how you number it. 10. So now let's name this. Bromo should come first, alphabetical order, then chloro. This guy sitting here is ethyl. There is a methyl here, there's a methyl here. The methyl will always come at the end now. So it looks as 3 bromo, 7 chloro, 8 ethyl, and we have 1 methyl sitting at 6 and 1 methyl sitting at 9. So it should be 6,9 dimethyl. And how many carbons? 10 deca. And you got the alkene at 1 and 4, so 1,4-diene. Now there's a slight problem here. This should be 6, not 7, because 7 you have chloro, you got the dimethyl, 1 methyl sitting at 6 and not 7. So just take care of this part. It is 6,9 dimethyl deca 1,4-diene. So let's do one more. Now this is pretty complicated, I know, but then we got to understand, how to look for the parent chains and stuff. Now this is relatively easier, because if you go this way, there are only 2 double bonds, 2 multiple bonds. You go this way, you got 3 multiple bonds. So the parent chain is obviously this one. So here we don't have much of a problem in deciding the parent chain. That's pretty simple. So, and how do we do the numbering? Obviously we'll do the numbering from here, 1, because the double bond has to be given the lowest number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the side chains also need numbering. Some of them. This fellow and this one. So they need numbering, so we're going to number them separately. I'll first number the ring 1, 2. And then number the double bond, the other one, the one sitting at 4, 1, 2, 3. So how we are going to name this? Always write the parent first. The easiest way to do is write the parent first. The parent is going to be deca 1, 5-diene, 1, 5-diene, 7-ine. So write that first. Now write the substituents before that. Bromo goes first. 4 bromo. Chloro, I think there are 2 of them. So 2,10 dichloro. And then, what is the name of this one? This is going to be 1 methyl prop 2 enyl. 1 methyl prop 2 enyl. So it starts with methyl M, whereas this one is going to be 2-fluorocyclopropanil. So it's 2-fluorocyclopropanil. So I think the fluoro will come first. So first we got the bromo, then we got the dichloros, then we got the fluorocyclopropane, and then the other one. So this is the name. For bromo 210 dichloro 3,2-fluorocyclopropanil, and please make sure the bracket is closed here. Again, there's a mistake here. The bracket should get closed here. For 1 methyl prop 2 enyl deca 1,5-diene 7 ine. So this is the name of this particular compound. So I want you to practice more and go through this video once again if you want, and just try and make some structures of your own and try to figure out the names. And I hope this particular video helps you in understanding the naming of alkyl halides. Thanks for watching.